All right, so in this video, we're going to be looking at operations involving radical expressions. Okay, and I just want to do adding and subtracting on this one. Okay, and so I want you to think about way back. Think back to when you did problems like 3x minus 5x. Okay, or when you did something like 3 over 7 minus 5 over 7. Right? In order to be able to add variable expressions, they need to be like terms. And that meant they had to have the same variable part. Okay? And when you were adding or subtracting fractions, you needed to have like fractions. Okay? And what that meant is that the denominators had to be the same. Okay? So when you're adding or subtracting radical expressions, like radicals, have the same radical part. Okay. All right. So for instance, if we had 3 cube root of 7 minus 5 cube root of 7, the radical part is exactly the same. It has to be the same radicand, the same thing underneath, and it has to be the same index. Okay. Okay, so if that's the case, then you do like you did on the others, and you just say 3 minus 5x, that would have been negative 2x. 3 sevenths minus 5 sevenths, that would have been negative 2 sevenths. 3 cube root of 7 minus 5 cube root of 7 would be negative 2 cube root of 7. Okay, so you can combine them if they're like radicals. Okay, so that's what's going on with number 16. Exactly what's going on, basically. You have negative 6 cube root of 5 plus 4 cube root of 5. So that equals negative 2 cube root of 5. The radical part was exactly the same. That meant I could go ahead and combine them, and that would be my final answer. Notice nothing changes about the radical. It stays cube root of 5. Okay. The key problem to kind of get at what can happen is you might be asked to do something like square root of 18 plus 9 square root of 32 minus 3 square root of 72. And so right now doesn't look like there's anything you can do because the radicals are all different. Okay, but if you wind up simplifying, we're going to see what happens when we simplify. So what I'm going to do, let's go ahead and take a moment just to break down all of these numbers we have under the radical. Okay, so let's take the 18 first and see what it breaks down to. So it's 9 and 2, it's 3, 3, and 2. Okay, 32, that one just turns out to be a whole bunch of 2s. I think it's 5 of them. Yeah, 5. Okay, when you break it down. Okay. And then we have 72. And 72 is 9 times 8. That's 2 3s and 3 2s. Okay. So we'll use that information when we wind up simplifying the radical part. Okay. So let's work on that. So the 18 right here, since there's a pair of 3s, would be a 3 outside and a 2 underneath. All right, now these other two are a little tricky because see that 9 that you had already? That's already there outside. Now you're looking at your 32 and you're seeing that you've got 2 pairs of 2s. So you're going to be able to bring out a 2 and another 2 for each of those, but there'll be 1 2 trapped underneath. All right, then you see how on this one, there's a 3 outside already. But then when you simplify side or factored 72, you notice there's 2 3s and 2 2s. So you'll be able to bring out another 3, a 2, but then there's this one leftover 2 right there that would stay underneath, okay? All right, so let's take a look at what we have right now then. So we have a 3 square root of 2, and then here really the 9 times the 2 times the other 2. That would wind up being 36 with the square root of 2. Then a 9 times 2 would be an 18 with the square root of 2, and it was a minus in front of that one. So you see how once we simplified, we now had the same radical part. These are like radicals. So now we're just going to combine them just like we would if combining like terms. So we'll say 3 plus 36 is 39 minus 18 square root of 2. And then 39 minus 18 would be 21 square root of 2, and we would stop there. Now, had one of these turned out to be a different number under the radical, we would be in trouble. And if one of them wound up having a different index, like a cube root instead of a square root, we couldn't have combined them all, okay? So you got to watch for your like terms. So you start out by taking the radical part, getting it simplified. You see how we did that? Okay, then when you take a fresh look at it, you notice you really do have like radicals and you're able to combine them. Okay, so that's adding and subtracting. All right, let me